Amazon SAP-C02 exam practice questions with explanations are available in the video for you to study. A company has a set of AWS Lambda functions serving HTTP requests from multiple IoT devices. Some older IoT models do not support specific HTTP headers, causing request failures. The company wants to migrate to AWS and keep compatibility with those legacy devices. Which solution meets these needs with minimal operational overhead? A. Use Amazon API Gateway to trigger Lambda functions and configure response mapping templates to remove unsupported headers based on the user agent header. B. Deploy Lambda functions behind an application load balancer and use a CloudFront function to strip headers. C. Use CloudFront with Lambda at edge to detect legacy devices and remove problematic headers before sending responses. D. Implement a network load balancer with Lambda integration and configure TCP header filtering logic. The answer is C. Using Lambda at edge with Amazon CloudFront provides the flexibility to manipulate responses at the edge, including the removal of specific headers based on conditions like the user agent header. This design supports legacy devices that cannot handle certain HTTP headers, maintains a serverless model, and requires minimal administrative effort. Unlike ALB NLB-based solutions, it avoids additional infrastructure management. The configuration is centralized at the CloudFront distribution layer. Therefore, it satisfies both cost and operational efficiency requirements. A company needs to migrate a monolithic web application running on EC2 into a containerized architecture. The workload experiences variable traffic, and two separate environments, production and testing, are required. The company prefers a fully managed, serverless container solution. Which option is the most cost-effective? A. Host the containers on Amazon EKS clusters with EC2 nodes and configure auto-scaling groups. B. Deploy containers on Amazon ECS using the Fargate launch type for both environments. C. Run the application on Elastic Beanstalk using separate EC2 environments for each deployment. D. Package the containers into Lambda functions and expose them through API Gateway. The answer is B. Amazon ECS with the Fargate launch type offers a fully managed serverless container platform that automatically handles scaling and eliminates the need for EC2 instance management. It is more cost-efficient than EKS for smaller workloads and simpler than Beanstalk for microservices. ECS supports multiple environments and isolates workloads cleanly. Fargate's pay-per-use model ensures cost efficiency during fluctuating demand. Therefore, ECS Fargate aligns perfectly with operational simplicity and minimal cost. A company operates an application hosted on EC2 instances in multiple availability zones behind an ALB. It maintains a warm standby environment in another AWS region for disaster recovery. To achieve an RTO under 15 minutes without active configuration, which approach is most effective? A. Configure Route 53 health checks with failover routing and a Lambda function to promote the read replica database during failure. B. Enable latency-based routing to both regions and promote the replica database manually. C. Configure global accelerator with equal weighting between endpoints. D. Maintain identical auto-scaling settings across regions and rely on manual switchovers. The answer is A. Implementing Route 53 failover routing with integrated health checks allows automated redirection of traffic when the primary region becomes unhealthy. A Lambda function can automate RDS read replica promotion and scaling actions in the standby region. This configuration achieves the desired RTO without requiring active costs. Using CloudWatch alarms and health checks ensures timely and reliable detection. It's the most cost-effective and automated DR solution for standby environments. A company's web application runs on EC2 with Elasticache Redis and RDS MariaDB. Each component must recover automatically from failure. Which combination of changes increases resilience? A. Add a multi-as RDS deployment and Elasticache replication group with multi-as enabled, and distribute traffic across EC2 instances using an ALB and auto-scaling group. B. Convert RDS into a single as deployment and replicate data manually. C. Replace Redis with DynamoDB and use CloudFront caching. D. Configure EC2 instances in one as with manual restart procedures. The answer is A. A multi-as configuration across database and caching layers guarantees automatic failover and minimal downtime. Elasticache replication with multi-as ensures continuity of in-memory data. Combining auto-scaling and ALB ensures EC2 fault tolerance. Each component contributes to overall high availability while maintaining managed recovery capabilities. The architecture minimizes manual intervention and meets recovery objectives effectively. A retail website served through CloudFront and ALB occasionally returns HTTP 502 errors. While debugging continues, the architect must show visitors a custom error page instead of the default ALB page. What is the best way to achieve this with minimal effort? A. Configure CloudFront custom error pages stored in an S3 bucket. B. Use Lambda at Edge to intercept 502 responses and replace them with static HTML. C. Create Route 53 failover records that point to a backup S3 static website. D. Modify the ALB target group to route 502 responses to another instance. The answer is A. Configuring CloudFront custom error pages stored in Amazon S3 allows user-friendly fallback without altering backend logic. CloudFront automatically displays the custom error content whenever the ALB returns a 502. This design avoids deploying Lambda functions or secondary instances, minimizing operational complexity. It also leverages existing CloudFront infrastructure for global distribution and low latency. Therefore, option A is the most efficient and scalable choice. A company using multiple AWS accounts under AWS organizations wants to centralize its network while allowing teams to deploy resources in shared subnets. What should the architect implement? A. Create a shared VPC in the infrastructure account and use AWS Resource Access Manager (RAM) to share subnets with member accounts. B. Deploy identical VPCs in each account and use VPC peering connections. C. Create multiple direct connect gateways to connect accounts. D. Allow each account to create its own VPC and connect through site-to-site VPN. The answer is A. AWS Resource Access Manager, RAM, allows subnet sharing across accounts within an organization. A central VPC managed by an infrastructure account simplifies governance and networking. Member accounts can deploy resources in shared subnets without managing their own VPCs. This approach enforces least privilege network management and centralizes control. It aligns with multi-account best practices recommended by AWS. A company must consume a third-party SaaS API hosted in AWS while maintaining private connectivity that doesn't traverse the Internet. What solution ensures compliance with internal security policies? A. Use AWS Private Link to create an interface VPC endpoint connected to the SaaS provider's endpoint service. B. Establish a VPC peering connection to the provider's VPC. C. Create a site-to-site VPN between the VPCs. D. Expose the SaaS endpoint publicly and restrict by IP allow lists. The answer is A. AWS Private Link provides private connectivity between VPCs and supported AWS services or SaaS providers over the AWS internal network. It avoids public Internet exposure while maintaining low latency access. Security groups can further restrict endpoint access by source. This model fully complies with no Internet traversal policies and eliminates the complexity of VPN or peering management. It's the most secure and operationally efficient option. A company wants unified visibility of patch compliance across all servers, both on-premises and on AWS. What solution meets the requirement with the least operational burden? A. Use AWS Systems Manager Patch Manager to manage and report compliance for EC2 and on-premises servers. B. Use AWS config rules and export data to Amazon QuickSight dashboards. C. Create custom scripts and aggregate patch data using AWS Lambda. D. Implement AWS Inspector for both EC2 and on-premises systems. The answer is A. AWS Systems Manager Patch Manager provides a centralized patch management and compliance reporting solution across hybrid environments. It supports both on-premises and AWS instances through the Systems Manager agent. Compliance reports can be generated automatically. The service reduces administrative overhead compared to custom scripting or manual tracking. Thus, it is the most straightforward and scalable solution. A company's auto-scaling EC2 group uploads log files to S3 every 15 minutes. Some logs are missing after instance termination. How can this issue be resolved? A. Use an auto-scaling lifecycle hook with a Lambda function that invokes Systems Manager to copy logs before termination. B. Enable S3 event notifications to pull logs on instance termination. C. Schedule cron jobs to upload logs more frequently. D. Use instance metadata to trigger file uploads upon shutdown. The answer is A. Adding an auto-scaling lifecycle hook for the terminating state allows custom actions before instance shutdown. A Lambda function can use AWS Systems Manager send command to execute log upload scripts, ensuring no data loss. This automated mechanism prevents abrupt termination before uploads complete. It's a standard AWS pattern for graceful EC2 termination. The solution ensures data durability without manual intervention. An organization uses private Route 53 hosted zones in Account A while applications and databases run in Account B. Instances in Account B cannot resolve internal DNS names. What should be done? A. Authorize and associate the private hosted zone in Account A with the VPC in Account B. B. Create duplicate private hosted zones in both accounts. C. Configure conditional forwarding on VPC DHCP options. D. Create a public hosted zone and mirror private records. The answer is A. To enable cross-account private DNS resolution, a Route 53 association authorization must be established between the hosted zone owner, Account A, and the consuming VPC, Account B. Once associated, instances in Account B can resolve records defined in Account A's private hosted zone. This avoids duplication or exposure via public zones. It's a secure and AWS recommended cross-account DNS setup.